perpendicular lines. So these are not ones that are like really brand new. It's kind of common sense. I'm going to ask you to help me think about it. And then I'm going to illustrate it down here. Transitive property of parallel lines. If one line is parallel to another line, like this one, if A is parallel to B, put the little parallel markings on. If those two are parallel, but at the same time, B is also parallel to C, what do you think is the relationship between A and C? They're parallel. Yep. So two lines are parallel to the same line. Then they are parallel to each other. So same thing here. They can go slanted. If this line is parallel to this line, which is parallel to this line, you can say that all three lines are parallel. All right, the next one. Just looking at this picture here from what we already know. Tell me what you see in that diagram right there. The right angle, 90-degree angles, perpendicular lines, good. You see one line that's perpendicular to D, and you see another line that's perpendicular to D. Two lines are perpendicular to like a wall right here, another line. Okay, they both have 90-degree angles. What kind of angles are these right here? Starts with C. Corresponding, good. And when corresponding angles are equal, then the lines are parallel. We'll review all that stuff tomorrow. But what this is saying is that two lines are perpendicular to the same line. If two lines are perpendicular to the same line, what do you think happens to those two lines? Right here, A and B. They're parallel, that's right. Then they are parallel to each other. If two lines are perpendicular to the same line, 90 degrees and 90 degrees, then they're parallel to each other. So for instance, if this red line is perpendicular to the blue line, and this red line is also perpendicular to that blue line, what happens between the two red lines? What are they? Parallel. And the last one. What clues do you see in this picture already given? What do you know? These three are parallel. Good. What else do you see?
A right angle.
A right angle? Only on one of them this time, not on all of them. Okay? The line is perpendicular. You can use the perpendicular symbol, but I'm going to just write it out. Perpendicular to one of two parallel lines. So if two lines are parallel and one line goes through it at a right angle, what do you think is going to happen at this angle? What's it going to end up being? If you have these two lines already marked parallel by the red markings, and you know that this one's a right angle, what's this angle have to be? Another right angle because of corresponding angles. Right, and this one would also end up having to be perpendicular to it. So if you already know the lines are parallel, and one line comes through it at a right angle, it's going to go through all of them at right angles. Okay, so this is only true if all the lines are in the same plane. It doesn't count for if you're going off in all directions. So let's look at example 1. You are given that D is parallel to E. So since they told us that, we're allowed to mark it on our picture. D is parallel to E. That was given. What else is given to you? E is parallel to F. So the same marking on the E can also go on the F. So we're going to prove this theorem. We can't just use it because we're actually proving it. So because it's given that D is parallel to E, angle 1 and angle 2 are supplementary by what reason? What makes angles supplementary? Same side interior angles theorem. Good. So fill in the blank right here. Angle 1 and angle 2 are supplementary by the same side interior angles postulate. They use the word postulate, but we use the word theorem. It means a rule. Okay. When two lines are parallel, these two lines, or these two angles, are supplementary. Because you know that E is parallel to F, these two right here, which two angles are congruent then? Look at the E and the F. Which two angles are equal? The what? Look at, let me block this off. Look at just the E and the F. Ignore the top one for a second. Look at just the E and the F. Which two angles are equal to each other? 2 and 3. By what reason? Corresponding angles theorem. You said that? I didn't hear it. I'm sorry. Corresponding angles theorem. They have the word theorem down here for you. You would only use the converse if you were going backwards, saying the lines are parallel. Alright, so by substitution, we can take this statement, I'll put it in pink, this statement right here, angle 1 is supplementary to angle 2, but at the same time, angle 2 is equal to angle 3. So substitute 3 in place of 2. Put it right here. What could you say instead? Angle 1 is supplementary to what? Angle 3. Good. So that goes right here. So all we have is angle 1 is congruent to angle 3. Oh, I'm sorry, supplementary to angle 3. These are supplementary, and when two angles are supplementary, same side interior angles are supplementary, what does that mean about the lines? The angles equal 180, and what do you know about the lines around them? What kind of relationship does line D have with line F? Parallel, because of the converse. So you have to use the converse rule this time. Because we said that the two lines are parallel. E is parallel to F. Sorry. We said that the two same side interior angles are supplementary, which proves that the lines are parallel. That's when you do the converse, when you're proving that lines are parallel. Are you good? Alright, you're given that AB is perpendicular to BC. That means there's a right angle there. That's what perpendicular means. You're given that angle 1 plus angle 2 adds up to 180. These are supplementary right here. Okay, that's what you're given. So let's look at what we can do. Actually, before we even look at the proof, let's think about it. If 1 is supplementary to 2, which two lines are parallel? Name them for me. You're going to have some like this on your test. I'm going to tell you two angles that have a relationship. What can you say about the lines? If angle 1 and angle 2 are same side supplementary, which two lines have to be parallel? AB goes through the 1. BC goes through the 2. Okay, good. That's what you're coming out with. So, angle 1 plus angle 2 is 180. That was another given. They wrote down one of your givens, then you have to write down the other given so that you can use it. Angle 1 and angle 2 are supplementary. That only comes from the fact that they add up to 180. That means you're using a definition. Supplementary means 180. So if two angles add up to 180, then by definition they are supplementary. So that's the definition of supplementary. Now look right here. They use the word converse. When you're using converse, like on that quiz I passed back, when you're using converse, you are saying that I'm going to prove to you that two lines are parallel. And we kind of already did that. Look right up here. AB is parallel to what? AB is parallel to what? DC. Good. So write that in now. Kind of already thought it through, but now write it in. Because of the same side interior supplementary angles, by the converse, you can say that these lines are parallel. But it uses the converse of the same side interior angle theorem because it's going backwards. You don't know the lines are parallel, you just proved that the lines are parallel. And now look what we have. We have two red parallel lines, and we have a blue line, if I can find blue, a blue line that's going through both of them, and that blue line makes a right angle with one of them. What has to happen at the other one? It has to be a right angle as well. So we're going to say that BC is perpendicular to CD. And the reason is one of your theorems up top. It's the one that says If a line is perpendicular to one of two parallel lines, then it's perpendicular to the other. This one doesn't have a special name, so we're just going to write out the actual statement. And you can abbreviate. You can use the perpendicular sign if you know it, or you can just copy it out.